So now let's talk just a little bit informally about what we mean by the limit of a sequence. So let's say we have a sequence Cn, 1 over n, like this. Then what is its limit? Well, its limit is whatever this tends to when n gets larger and larger and larger. And here we can see that as n grows, 1 over n will tend to 0. So a mathematician would then write that this tends to 0 as n becomes infinitely large, tends to infinity. Or we would write that the lim of Cn, which is then 1 over n, is equal to 0 as n tends to infinity. So this lim notation is the notation for whatever this is tending towards. And of course, saying tending towards is very informal. Should perhaps say that Cn gets arbitrarily close to 0 as n grows to infinity. That would be more accurate. But to be completely accurate, we would need the formal definition of the limit. And since that definition is slightly complicated, we're postponing it a little bit longer so that we can get some intuitive feeling for this concept first. So this is basically one example. And if we do this, if we look at this visually, we could see that, well, for n is equal to 1, n is equal to 2, 3, and so forth, we're getting the value 1 here, a half here, a third here, a quarter here, and so forth. So we're seeing that these guys are decaying to the height y is equal to 0. So that's another way of looking at it. To take another example, we could do Cn is equal to minus 1 to the n. And then we can start this. So let's say that we're doing this for n in the natural numbers where we start with 0. Here we could do something similar like this. We have 1, 2, 3, 4, and so forth. And 0 also, let's include. So for 0, we're here at 1, minus 1, 1, minus 1, 1, and so forth. And as n tends to infinity here, grows bigger and bigger and bigger, there is no fixed value. There's no single y value that this tends towards. So here we say that lim n goes to infinity Cn does not exist, or we can say that it diverges. So these are two common ways of expressing this. Up here, we would say that this limit converges to 0, or we would just say, if we don't care about the value 0, just that it converges to something, we should just say that he is convergent, or converges. We can do another example. For instance, we could do Cn is equal to n squared. Now this guy will get bigger and bigger and bigger. And if we do a drawing here, we would see, well, it would follow the parabola. So it would be here, 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 and so forth. And this guy also diverges. But here, since he becomes infinitely large, we have a special way of expressing this. So here we would say that lim Cn is equal to plus infinity. This does not mean that this thing here is equal to the number plus infinity. It's just a way for us to express that this guy diverges, and he does so by becoming bigger and bigger and bigger. So there's a special meaning to all of this symbol. So you shouldn't view this as left-hand side being equal to right-hand side. You should actually view this as one composite symbol, if you want. And we could also express this in that way. So we could write Cn goes to plus infinity as n goes to infinity.